Welcome
to
Topic
7.1 Integral
as
Net
Change. Woo! What is an integral?
The integral can be basically defined as the area under the graph of a function. For example, here is the graph of f of x. The integral from point A to point B would simply be the area under the curve as illustrated by the purple. This is Jack, the tiger. And here's Chris, the skateboarder. Watch as Chris rides his skateboard in a straight line on this sidewalk, back and forth past Jack.
This is a graph of my velocity while I was on my skateboard outside. The area under the curve represents my displacement from Jack at any given time t. Suppose we want to use 5 as the time I want to figure out displacement that was from Jack. We would just fill in the area under the curve up until 5, like so. And then from there, we would add the positive and negative areas to get the displacement I was from Jack at given time 5. And that's it. Sound hard to believe? Let us illustrate this with an easier example. Suppose our special guest of honor plays scales at 6 notes per second. Stephanie's piano playing is shown by this graph in notes per second and time in seconds, t. To see how many notes she's played over a 5-second period, we mark over along the x-axis till 5. You'll see that makes a rectangle with a height of 6 and a length of 5. You calculate the area by doing 6 times 5, which gives you 30. Using an integral, we can let f of x equal 6. We're going to take the integral of 6 from 0 to 5, using from 0 seconds to 5 seconds along the x-axis. The integral, or antiderivative, of 6 is 6x, which we will evaluate from the bounds 0 to 5, giving you 6 times 5 minus 6 times 0, which equals 30, giving you the same area when you use a rectangle.
okay. Back to the example of Chris's skateboarding. This is the graph of Chris's velocity. We want to find his position function. So, in order to do that, we integrate it. And the integral of cosine of 4x is equal dx equals 1/4 sine of 4x plus c. And this function defines Chris's position.
I love calculus. This is an average household sink
and I am going to graph the rate of consumption in a 40-second period.
So this graph is the rate of water consumption over a period interval from 0 to 40 seconds. If we take the area under the curve, we find the amount of water used in that time period. So the area under the curve is the integral of r of t, which is the rate. And we want from 0 to 40, 0 to 40 equals the, I'll call it s of t, the amount of water used from 0 to 40 seconds. And now, if I wanted to know the amount from 0 to 30 seconds, I would do the integral of r of t 0 to 30, which is equal to s of t from 0 to 30 seconds.
In the previous example, Samuel forgot to write dx after the integral. This is extremely important. Do not forget the dx. Here's another mistake to avoid when using integrals. Before we proceed, let me remind you, do not try this at home. We are going to lure an unsuspecting calculus high school student as a victim to see what happens when we divide by 0. Samuel, call in the unsuspecting victim.
Hey Luke, can you come here for a sec? We need your help with a math problem.
Oh,
sure.
For this.
Well, hey buddy,
What's going on?
I can't integrate this problem here, and I was wondering if you can help me out. You know me.
1 over x squared from 0 to 7? Shouldn't be too hard. Okay. Just set up the problem.
Intriguing. Yes.
Ah, I see.
How do we not see that?
-1 over 7 plus